Now, fallacies and heuristics go hand in hand because the application of certain heuristics can lead to fallacies. So can lead to bad lines of reasoning and bad arguments. Here is a classic example. Say that you are playing a new game called the mini roulette. It's exactly like a regular roulette, except it only has 6 numbers from 1 to 6. Okay. Now, as you play nearby you, and you can see it pictured right up here, there is the history of the previous results. And in fact, these are the last 21 results. Give them a look. Now, let me ask you this. Here we are, we're about to spin. How likely do you think it is that at the next spin, a 5 will come out? Take a look at the history, and then, think which of these probabilities is the closest to what you might imagine. Somewhere close to 60% or 45% or 30% or 15% or 1%, et cetera, et cetera. What would you pick? How likely do you think it is that 5 will come out at the next spin? Now, see, very often people respond to this question by saying 30% or even 45%. And see, this is because people seem to have an intuition as they look at the historical outcomes that 5 hasn't quite come out for a number of times, right? You can see it here. It came out at the beginning, and then we haven't seen a 5 for a while. And so this gives the impression that 5 is somehow, due to come out, and that makes it more likely to come out. Now, of course, this is impossible. At every spin of the wheel, every number has the exact same probability of coming out, 1/6, right? So close to 15, 16%. Right? Just because a number hasn't come out a number of times doesn't make it any more or less likely to be the number that comes out at the next spin. The events are completely independent of each other. And this is known as the gambler's fallacy, the mistaken belief that the probability of a random event, so what number will come out at the next spin, is influenced by previous random events, which is the history of which numbers have come out so far. And it's a very powerful intuition, and that's exactly why if you ever go to somewhere where they play roulette, they will very often show you previous results, and the same is true with the lotto. They always show you previous results from prior lotto extractions, and people get very busy with trying to predict which numbers are more likely to come out or are due to come out at the next time. Of course, at every draw, if something is a random event, it has the exact same likeliness to come out, regardless of how recently it has come out. And see, this is an example of the representativeness heuristic gone bad, so to speak. You expect a sequence of random events, of random draws, to be representative, to look like a random process. So this somehow generates the expectation that if it's a random sequence, it should look random. So you should kind of keep seeing the numbers come out in some random order. If suddenly a number doesn't obey this perception of what is a random sequence, somehow it's more likely to occur because it has to complete the pattern. It has to make the pattern representative of a random number. And of course, this sort of line of thinking from the representativeness heuristic leads us to commit the gambler's fallacy. Another classic example of fallacy was studied in 1973, again by Kahneman and Tversky. In fact, let me give you the problem that they used. Linda is 31 years old. She's single, outspoken, very bright, majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which of the following you think is more likely to be true? That Linda is a bank teller and is also, today is a bank teller and is also active in the feminist movement, or that Linda is just a bank teller? Which of the two you think is most likely? See, interestingly, 85% of the people tend to pick option A. Tend to pick the idea that Linda is both a bank teller and an active in the feminist movement as being the best answer. Yet, this, of course, is a fallacy, which is known as the conjunction fallacy. There's no way, it cannot be more likely that somebody is at the same time a bank teller and something else, in this case, active in the feminist movement. That cannot be more likely than somebody just being a bank teller alone. If you look at it with this Venn diagram, if this is the set of all bank tellers, right, there is some subset of it, which is the subset of bank tellers who also happen to be active in the feminist movement. You cannot have somebody who's both a bank teller and active in the feminist movement. That cannot be more likely than somebody just being a bank teller. It just logically, it doesn't work. And this is what we refer to as the conjunction fallacy, this sort of the mistaken belief that it's more probable for somebody to be at the same time A and B, and that is more probable than this person being only A alone or B alone. And see, again, this is a result of the representativeness heuristic gone bad. See, in the sense, option A, the bank teller and active in the feminist movement, is more representative of who Linda is based on the story that you read about her. Even though logically it's not the correct answer, it better suits, it better represents who Linda is. And so representativeness again leads us down a logically incorrect answer.